One of the most common software best practices when it comes to code, which is much easier to test and maintain, is to use dependency injection. An obvious benefit, which might be hidden from most developers, is that you've reduced the duplication when it comes to creating complex objects. And I'm going to show an example of this benefit. But let's start with a reminder of what dependency injection is. A quick explanation of this design pattern. When you have a class that needs to use other services or other classes, instead of manually creating those services within the parent class, delegate this responsibility to some other specialized component. So, for example, this transaction processor doesn't use dependency injection. The external services it needs, which are inventory manager and email services, are being instantiated within the transaction processor itself. Now, this code is going to compile and work without a problem, but it is very hard to test because it needs to use a real concrete inventory manager and a real email service, which means the tests are now basically just end-to-end. This would be opposed to maybe testing a partial functionality. To test inventory manager would mean we're going to have to send out a real email, or we're going to have to deal with real inventory. This class, as it stands right now, it's not flexible enough to allow fake versions of inventory manager for testing. So fakes or mocks. So we can't substitute those or inject them into it. With dependency injection, these two classes or dependencies are passed into the transaction processor, and they can be mocks or fakes. So we don't have to really send out an email. We don't have to be hitting a real database that updates the inventory. Transaction processor now is also no longer responsible for creating real instances of its dependencies. But now these are now injected or passed into the constructor. The specialized thing or component that creates these instances or dependencies, this thing that's going to inject them into the class, that's called a DR container. So the benefits of dependency injection are, for one, it's code that's easier to test because we can substitute the real versions or the real instances with mocks or fakes. Code becomes easier to maintain and extend because components or dependencies can be swapped. Classes and services become more focused, and they no longer have the responsibility of creating and managing instances or dependencies or their lifespan or life scopes. If you have a very, very small application, potentially you could get away without using dependency injection. But once the system starts to get very large and the code base gets bigger, and then you need a whole lot of different test classes or test instances, then dependency injection is going to make a whole lot of things a lot easier. One of the hidden benefits is that the logic for creating complex objects only needs to be declared once in the DR container, and it doesn't have to be repeated. This is actually one of the clean code principles. Dry is a much easier concept to understand, which basically means that do not repeat yourself. So every time that you find yourself copying and pasting or where you have a lot of duplication, if you're doing this multiple times, whenever there's a change, you are then going to have to go to all the instances. You might forget one place where you have to change or update that copy and paste. Looking at this diagram, transaction processor has the two dependencies, inventory manager and email service. And both of these themselves have dependencies which are database service and logger. Now, the chain continues because database service, that in itself can be a little bit complex because eventually we're going to need an actual database store, which could be a number of different providers such as MS SQL, MySQL, flat files, or just using an in-memory store. The provider is an abstraction or an interface, meaning a real concrete provider needs to be resolved or instantiated somewhere eventually. And this is typically done in the DR container. Without dependency injection, we would have to manually create this long chain of dependencies every time we need it. So database service can potentially have the same instantiation code, which we're going to have to copy and paste every time, like between inventory manager and email service. They're both using database service, and to instantiate this thing, we have to copy and paste that long chain of code, and this is not dry. A much cleaner way and one that is more maintainable, where there's less clutter, would be to register each class once in the DR container. And in this instance, I'm using autofac. Now, the good part is that a developer does not even have to know which class is a dependency. So there's no need for a developer to think hard about manually passing the dependencies into a constructor. The DI or autofac is going to automatically handle this part. And looking at this autofac class, I'm only using it for registering the classes. For example, towards the end, there's no notion of keeping track of which dependencies. As a developer, I'm not having to think about this part. If you go back to this diagram again, transaction processor can get very complex to instantiate. And we only just need to register this transaction processor and not even have to explicitly state its dependencies. So as the code evolves, the constructor signature gets updated. So we're adding more classes, or we're removing some dependencies we feel we no longer need. We're only going to make this change in the constructor itself, because the DR container is going to do the auto wiring. Now, another benefit, if in future, let's say we have a completely new class, analytics manager, it might also make use of database service or logger. And to wire up analytics manager might only actually just take up the one line in the DR container, because now the database service and the logger have already been registered in the autofac. Yet another scenario where a DR container is going to make life very, very, very easy on a very large system is if we have a separate test project. So we could think of this entire system, one for running it, using it in a live scenario where you're actually using the code. And then the other part where we actually need to run test classes or test cases. So if we're having something like an integration test where you have to actually create a whole lot of instances, the DR container is going to automatically resolve those complex dependency chains. So just to recap, the dependency injection pattern has the obvious benefit of making a code base more testable and much easier to evolve. But another benefit, which might not be as obvious, is the DR container becomes a centralized place where components can be registered. The developer does not even have to think or keep a very serious mental note of long complexity chains. Even the instantiation of dependencies is done in this one place, which is the DR container, making code dry.